In the previous video, we looked at the multiplication rule for two tasks, and that was very simple. If the first task could be done in, say, 4 different ways, and the second task could be done in 5 different ways, then the total number of ways you could do task 1 followed by task 2 would be 4 times 5, or 20. Well, in this video, we're going to talk about the general multiplication rule. It basically just means you don't only have to have 2 tasks. This will apply even if you have 3 or 4 or 5 or 50 or 100 or any number of tasks. So, suppose we have tasks T1, T2, all the way up to TK. So how many tasks is that in total? It would be K, whatever that number is. If K is 10, that would be 10 tasks. So suppose those tasks can be performed in this many different ways respectively. So that means that task 1, T1, can be done in this number of ways, N1. N1 is just a number. It could be 5 or 3. Task 2 can be done in 2 different ways, and then task K can be done in K different ways. So this is K numbers corresponding for the number of ways that each of these K tasks could be performed. Well, if that's the case, then the number of ways a person could perform task 1, followed by task 2, followed by task 3, followed by ... all the way to task K would simply be this. Let me write down T1 there, T2 there, T3, ... TK there. I'm going to write the answer on top of the line. How many ways can task 1 be done? Whatever N1 is, whatever that number is, we're using the variable N1, times N2 times N3 times ... all the way to N sub K. Sorry about that. N1 times N2 times N3 all the way up to times Nk. So you're just multiplying all these numbers together, and that tells you how many ways you could perform task 1, then task 2, then task 3, and so forth, all the way up to task K. So that's the general multiplication rule, which we're going to use now in several examples. Okay, an exam consists of 8 multiple choice questions, each with 4 possible responses, A, B, C, or D. So the answer key could look something like this. And for number 1, all you have to do is circle one of those, and it goes all the way down to 8. So you'd have 8 of these choices, 4 choices for each one of the questions. In how many different ways could that exam be answered? Well, let's first define what our tasks are in this thing. I know each question can be answered in one of 4 different ways. 4 choices. So I'm going to call that task 1, and then task 2 would be number 2, task 3 would be number 3, all the way down to task 8, which would be number 8. So we have essentially 8 tasks. Each one has 4 possible answers, 4 possible ways to do it, 4 possible choices. So 2, 3, 4, 5, 6, 7, 8. These represent our 8 choices, and now our 8 tasks, and how many ways can we do them? Well, we can do the first one in 4 different ways. We could choose A or B or C or D. Second one, same. And that's the answer. The best way to write that is 4 raised to the 8 power. I'm not even going to plug that into the calculator. On an exam, I prefer to see this. I know that you all know how to use a calculator. I really would love to see this picture even. So that really tells me you know what you're doing here. Okay, this is a perfectly good answer to leave it in that form. All right, number 8. Julie selects a sequence of 3 cards, one at a time, from a standard deck of 52 cards. Now, I'm assuming you know what a deck of 52 cards is like, but if you don't, it's perfectly fine. The deck is just the stack of 52 cards. So there are 52 distinct cards. And what does this little phrase mean, without replacement? So if I were selecting a sequence of 3 cards one at a time with replacement, I would pull one card out of the deck, Then I would put it back in and shuffle it, and then I would pull one more card out of the deck, and then I'd put it back in, shuffle them, and pull one more out, which means you could conceivably pull out the same card all 3 times. We're doing this without replacement. So when you pull one card out for the first one, the next card you pick is going to be from the remaining 51 cards. Okay? So, in how many different ways can the sequence of 3 cards be selected? So how many tasks are we doing? It's not 52, there are 52 choices, but we're drawing 3 cards. So 1, 2, 3. I like to draw, sometimes I'll call this a picture. It's not much of a picture, but this is like task 1, task 2, task 3. Draw card number 1, then draw number 2, and draw card number 3. So how many ways are you allowed to choose the first card? How many cards are there to choose from? 52. So you have 52 ways of choosing that first card. I kind of already gave you the hint here, but how many ways can you choose the second card? One of them is now gone. It's not being replaced in the deck. So now you only have 51 cards left. And after you remove 2 of the cards, you only have 50 cards left for choice number 3. So I'll let you plug that into the calculator. I prefer just seeing this answer just like this, 52, 51, 50, or just like this, either way. That is the answer. And by the way, that's a big number. Okay, last one in this video. A Rhode Island license plate. It consists of 2 uppercase letters followed by 3 digits. That describes all of the license plates. How many different license plates can exist in the state of Rhode Island? Okay, no 2 drivers can be driving 2 different cars with the same license plate. So all of them have to be different. So there's a certain number of plates that you could have in the state of Rhode Island. So let me draw my picture. What do we have? 2 uppercase letters. I'll put a little space there, and then 3 digits. Okay, we got to define some terms here. Well, first of all, you need to know how many letters there are in the alphabet, and that's 26. I'll just make that note up there. There are 26 uppercase letters. How many digits are there? Digits refer to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're also considered decimal digits. There are not 9, there are 10 because it goes 0 all the way up through 9. So there's a total of 10. Okay, so the very first character in a license plate is an uppercase letter. How many choices do we get? 26. Okay. The second one is also a letter. 26 times 10 times 10 times 10. Whatever that is, we could write it 26 squared times 10 to the third. I happen to know that's 676 with 3 zeros. So 676,000 license plates could be used in this format in the state of Rhode Island, or in any state that uses this form, 2 uppercase letters followed by 3 digits. Once again, this is a perfectly good way to leave the answer on an exam, or even this. Sometimes you will have to plug it into the calculator, especially if I ask you to do it, because maybe we'll do something else with that number. Okay, what if no letter and no number is allowed to repeat from these license plates? So the number is going to change. This restricts us, so it's going to be a smaller number this time. We're not allowed to let digits or letters repeat. For example, if this one is an A, this one cannot be an A. If this digit is a 6, you can't use 6 here or here. Can't reuse them. So 1, 2, 3, 4, 5. That's my picture of the plate. I'm basically going to write down the numbers of ways we can do each space here. The first one is an uppercase letter, 26, just like above. But how about this one? How many choices do we have now? A letter has been used here. Now it can only be 25 left. For example, if the letter L were used right here, well, there's only 25 letters left because you can't reuse the L. All right, then we get 10 digits. But no digit is allowed to repeat. 9, 8. And this is a perfectly good way to leave the answer, unless instructed on the problem to simplify it. That would mean plug it into the calculator and write it down.